Creating a WhatsApp chatbot and integrating it with GPT-4 is not rocket science. So today I'm going to show you how you can do this in this step-by-step tutorial. I'm going to use WebStorm for this tutorial, but feel free to follow along with your editor of choice. I'm going to utilize my Windows subsystem for Linux. I'm running this project on my Ubuntu box whilst being on a Windows machine. Install Node Version Manager first, and then use the Node Version Manager to install Node.js. To test whether our Node.js is working, let's type in Node in our terminal and say 1+1. For this tutorial, we are going to use NestJS. I prefer the opinionated approach of NestJS. So we need to install the Nest CLI. It will automate the creation of services, modules, and stuff. To create, build, and run a new NestJS project, we go to the parent folder and run the following commands: nest new, then the name of your project. I'm going to call it a tester chatbot. The Nest CLI will scaffold our new application. We then go to the newly created application folder and start our project in development mode using npm run start dev. Go to localhost port 3000. It returns hello world, showing that our application has been set up. Let us log in on the Facebook for Developers platform and create a WhatsApp application, the one we are going to do the integration for. Select other, click next. The application type for the WhatsApp chatbot is a business app. Then we add our application name, then select the business portfolio. You can use the test business for this example, or leave it blank and fill it afterwards, and create. On the list of integrations, go to WhatsApp and click setup. Select the business name, test business, then click continue. Our application has been created. One thing you have to note is when the application is being tested, like in this case, we're in a testing environment, you cannot randomly send to any person. You have to add phone number and then verify that phone number. After that is done, that's when you can be able to send WhatsApp messages to those test phone numbers. Let's click the send message button and test to see if everything is working. Yes, we've received a test message. To make your life easier, I would recommend forking this Postman collection so that we can use it as a point of reference when you are developing the chatbot. When you open your Postman, you will be able to see this collection and understand how the WhatsApp API works. The Nest CLI has a generator which we can use to create boilerplate code. To use the generator, you use the G command. Then you specify what you want to be generated. To create a WhatsApp module, we use NestG module WhatsApp. A module serves as a way of organizing and encapsulating the functionality of an application. Let's also create a WhatsApp controller. A controller is responsible for handling incoming HTTP requests and returning responses to the client. That's where we define the routes and endpoints for the application and then delegate requests to the appropriate services for processing. For this reason, we are going to create a service for our WhatsApp controller. The WhatsApp service is automatically registered in the WhatsApp module as a provider since we use the CLI. So it will be like this. The controller receives an incoming request. It then forwards that to the appropriate service for handling. To give you a glimpse of how to define an endpoint in NestJS, let's go to the WhatsApp controller and make a hello world equivalent for our API. We use the @get decorator to define a route handler for HTTP GET requests. Go to Postman and make a GET request to our WhatsApp test endpoint. We'll get the hello world response, confirming that our application is working. For us to be able to use the WhatsApp API, we have to go through the WhatsApp Webhook verification challenge, authenticating our application on the WhatsApp servers. Let's replace our test endpoint with the Webhook. We're going to use this route for verifying our server. Create a WhatsApp verification challenge function, and from that request, we then save the mode, the challenge, and the token. The token is something that we are going to create on our own, and then we save that same token on the WhatsApp platform, such that when it verifies our server, it sends the mode as well as the token, which matches the same token which will be on our server. If the mode and the token are not available, chances are high that the incoming request is not coming from the WhatsApp servers, or we have like misconfigured endpoints. So we return a message which says error verifying token. The mode is always going to be subscribe. So if the mode subscribe and the token from the WhatsApp servers is the same as the verification token that we have on our own servers, then we respond back with the hub challenge. That way we have authenticated our server on the WhatsApp Cloud API. To store our WhatsApp Cloud verification token, let's create an environment file. That's where we are going to save tokens and all other configurations, but make sure that you don't commit the environment file to any version control system that you might be using, because you might end up exposing sensitive information. So you should include it in the gitignore file such that when you commit your code and push it to version management systems, it's ignored. For Cloud API Webhook verification token, I'm going to utilize OpenSSL to generate a random cryptographic key, which is base64 encoded. We then save the generated cryptographic key as one line in the environment file. In order to expose our local environment over a secure channel, we're going to make use of Grok, which is a localhost tunneling software. It exposes our local environment to the internet and it provides a secure HTTPS channel. Since I'm on Windows subsystem for Linux, Ubuntu, I'm going to use Snap to install Grok. After the installation is done, let us log in and configure our agent. Copy the command in the dashboard and paste it on our command line. That authenticates our Grok agent. To expose our local host that is running on port 3000, we use Grok HTTP, then the port. We then take the HTTPS URL, and when we make a GET request to this, it responds saying error verifying token, confirming that our tunnel is working as expected. Let us try to configure our webhook on the Meta for Developers platform, URL/WhatsApp webhook, and then the verification token that we created using OpenSSL. Click verify and save. The verification process is failing. This is because NestJS doesn't work with environment file out of the box. We need to install the NestJS config module. After installation is done, we then import the config module in our application module such that it's available application wide. Click on verify and save. Click on message. Then we subscribe to the message webhook. Click done. Our application is now ready to receive and even respond to WhatsApp messages. Create a post route that will handle post requests from the webhook. We use the post decorator. So post webhook, then we specify the HTTP code 200 to specify that we've received the request. Otherwise, WhatsApp will continuously try to send us the post request. That's where the issue of like duplicate messages comes into play. Capture the message details. It's an array, but we just need the first index. And then from that message object, we take the message sent ID, which is message.from, and the message ID, which we are going to utilize later on to respond to specific messages. Based on the message type, we use a switch statement. The message types can be text, audio, images, but for now, we are handling incoming text messages. If it's a text message, the contents, which is the text, is found in the message.text.body. Having Postman will make your life easier when it comes to developing WhatsApp chatbots. Open Postman. We go to the post request responsible for sending text messages. Then we copy the JSON object. We encode it as a JSON string and replace the recipient phone number with the message send ID. Change the body. We need to install the Axios package to make a post request in NestJS. npm install Axios. Then we import the HTTP service from Axios in our controller and register it in the constructor. And we then go back to Postman, to the post request, which is responsible for sending message via the WhatsApp Cloud API. We click the code icon that will give us like the code snippet. Let us select Node.js Axios, copy the config object. Authorization makes use of a bearer token, which we are going to save in our environment in the .env file. Let's replace the version, phone number, ID, and also save it in our .env file. We can get a Cloud API access token from the Facebook for Developers platform under API setup, then temporary access token. Copy it and paste in our environment file. In the event that you want to use the same code or a different chatbot, it's a matter of changing the configurations. After that is done, let us use the HTTP service from Axios to make a post request, specify our URL, the data that is JSON serialized, and the configuration as well. And we pipe it since it's an observable, and we also catch any errors in the catch block and respond with an error message. Then in the pipe operation, if we catch an error, we are going to throw it so that it's caught by the catch block. Let us import a logger which is available in NestJS, so that we log any error messages, which is going to help us debug issues in our local environment. Say this .logger dot the type of log, based of whether it's an information log, error log, then the error message. And for us to get response value, we use last value from RxJS. As you can see, our controller is growing big. The more functionality we add, if we follow the same pattern, it will continuously grow. So as a rule of thumb, the controller should be lean. Hence, we are going to delegate all this logic. That's like sending the WhatsApp message to the WhatsApp service. Copy the code responsible for sending WhatsApp messages from the controller into the WhatsApp service. We then import the WhatsApp service in the WhatsApp controller. In our switch case, which is responsible for handling text messages, we then call the send WhatsApp message from the WhatsApp service. Specify the message sender. That way, we are forwarding WhatsApp message sending part to the WhatsApp service, and we keep our controllers lean. Reload our application, send a message to our bot. Our chatbot is not intelligent yet as it's responding with static message. So let's make use of GPT-4o and have it respond with intelligent responses. We're going to create a module for OpenAI using the NestJS CLI, NestG module OpenAI. Create a service for OpenAI as well using the NestJS CLI. Install the OpenAI package, npm install OpenAI. We import it in the OpenAI service and instantiate a new class. Specify the key. And then we create a boilerplate for a method which is going to generate the response based on user input and respond back to the user. We also import the logger as well, like that we can be able to log error messages. We make use of chatcompletions.create to make responses using generative AI. We specify the model. For this tutorial, I'm going to use GPT-4o. We're only targeting the first response choice, hence we're using response.choices 0 to target the first index. After that is done, we import OpenAI service in the WhatsApp service because we want to replace text body, which is saying message response from our bot, with the response from GPT-4o. Let's define a variable AI response, which we are going to get from the OpenAI service. We are sending our user input to the OpenAI service, then GPT-4 response. We replace the static message with the AI response. Save the API key in the environment file. A word of caution again, make sure that you are not committing and pushing the environment file to your version management system, whether be it GitHub and others. We go to platform.openai and then create our OpenAI keys. After it's generated, you won't be able to see it on the platform. So make sure that you save it somewhere. If that's sending a letter to your grandma with a key, so be it. Save it in the environment file. We also need to correct a minor error in our WhatsApp controller by supplying the text message to the send WhatsApp function in the WhatsApp service. Let us then send a message to our WhatsApp chatbot and see if it's going to respond using artificial intelligence. What is live? Yep, it responds with a philosophical answer GPT style. Our WhatsApp chatbot can only respond to the current message without considering the conversation history, like it doesn't have conversational context. So in the next step, I'm going to show you how you can also include the conversation history such that the chatbot considers what was said before. We are going to store our conversational context in Redis, as Redis stores data in memory, and it's extremely fast for read and write operations. For the purpose of this tutorial, I'm going to use a Redis instance from Upstash, which is a platform that offers Redis instances with a generous free tier. You'll be able to go through this tutorial without paying a dime. And building on the modular approach we were using before, let's create the user context module, the user context service. Go to Upstash, create the Redis database. I'm going to call it Artista Chatbot. Give it whatever name you need. On the Upstash dashboard, we have a guide which shows how we can connect to our Redis instance. Like in this case, we are using NestJS. We click on Node, copy the URL, save it in the environment file, install IO Redis, instantiate Redis, then supply the URL, the one we defined in the environment file. After that is done, create an asynchronous function that is responsible for saving the context to the Redis database. Put the boilerplate, the try and catch block. In the event that there's an error, we log that error using the NestJS logger like we were doing before. The order of the conversation matters. For this particular reason, we are going to make use of the list data structure. We are going to make use of a write push. Just now import the user context into the WhatsApp service such that every time that we receive a message from a user and get a response from GPT-4o, we save into the user context. We register the user context service in the constructor, register it as a provider in the WhatsApp module. That way it becomes accessible in the WhatsApp service. Import the user context in the OpenAI service. So the way we are going to go about it is when the generate AI response synchronous method is triggered, we want to fetch the conversation in history and include it as part of the message object that we are going to send to OpenAI API, thus making the AI context aware. To get the conversation history, we're going to invoke the get conversation history, which is part of the user context service, and supply it with a unique identifier that we can use to get the conversation history. On the WhatsApp platform, each phone number is unique, so we can use the user's phone number as the identifier to get the conversation history. Register the user context service in the OpenAI module as a provider. And in NestJS, a provider is a class that can be injected into other classes. Before querying the history, we need to make sure that we save the incoming message to the user context. That way, when we query the user context in order to get the history, the incoming message is also included. We are making two separate requests in this instance, but keep in mind that Redis is robust enough to the extent that we can combine these into one query. I'm going to show you how you can do that in a bit. Send a message which says hello bot to the chatbot. From the log, we can see that message object is JSON encoded. So to clean it up, go to the user context service and do a map on the list and JSON pass each item. There's some inefficiency in our code in the OpenAI service. Before generation, we are making a separate call to save to the user context or to save to history. And then we make another one to get the conversation history. We can optimize for this scenario using a Redis pipeline. The way a pipeline works is it enables you to combine two separate requests and have them executed as a single operation. That's a single round trip. Create a save and fetch context method in the user context service. Initiate a Redis pipeline. Then we add the code which is responsible for getting the conversation history to the pipeline. To get the result, run the asynchronous execute method on the pipeline, await pipeline.exec. The result is a subarray which contains information for the first command, which is the write push, and the last command, which is the conversation history. We can access the conversation context by accessing the second index of our array, which is 1, as indices are n-1. We map the conversation context and we go to the OpenAI service. Instead of saving to context and then getting the history, let's just call save and fetch context, because it's going to automatically save to context and return back the history in one operation. As the user context object or the messages object on the chat completions create. In the event that there's an error saving and fetching the context, it's return an empty array. We're going to make use of the save context, which is in the user context service. Then specify the context type to be system to highlight that this was generated response from GPT-4o and supply the user ID. After sending a message to our chatbot, we will see on the dashboard that the responses from GPT-4o are now also being saved in the user context instead of just the user's messages. They are being saved as system instead of assistant. So let's change from system to assistant, as system is used to specify system prompts. And the next step is giving our chatbot a personality. In this case, we're going to call it Artista and tell it about the things that it can do and make it aware that it's responding to WhatsApp. That determines how it's going to create the responses. You can even restrict it to say, don't do such and such. It's up to you. Include the system prompt. The row is system, then the content. And using the spread operator, we are supplying the system prompt as well as the user context. Our chatbot is taking shape, but there are also things we have to take into consideration. We are supplying the user phone numbers as they are, which is a security concern when it comes to production systems, because in the event that the data source gets compromised, the real phone numbers are exposed as well. So we need to secure these phone numbers. Make use of the crypto module, which is available in NestJS. Import the crypto module and create a function for hashing phone numbers. Supply the hashed phone number when we are pushing and getting the conversation history. As you know, there are limits when it comes to the context sizes. In the event that the context is full, you will start having errors. Considering a WhatsApp chatbot, it's quite rare that a user might want to refer to information they've asked like 24 hours ago. We are going to make use of a mechanism where the user context gets deleted on a rolling basis. When it comes to Redis, the list data structure has a time to live. Go to the user context service and use the Redis expire command and set the context expiration time to 10,800 seconds. The context will get deleted 3 hours after the last conversation. In the save and fetch context, we also add the expire command as part of our pipeline to make sure that it's still being executed in a single round trip. When we send a message to our chatbot, if we go to the record, now here's a time to leave, which is the expiration time. The context is automatically deleted after the time to leave lapses. That way we are not storing conversations permanently. To enhance the user experience, let me show you how you can respond to a specific message, which is the equivalent of highlighting a message and responding. Let's go to the data object that we are sending when we are posting to the WhatsApp Cloud API. Supply the context, which contains the message ID from an incoming message from WhatsApp. And if we are to test our chatbot, the message to which we are responding to is automatically highlighted. Another nice to have is acknowledging when we receive a message from a user. Those blue ticks, which happen when someone opens your message, we can achieve the same using the WhatsApp Cloud API. Let's create a mark as read asynchronous function. Let's go to Postman and see how best we can do it. You'll see that from the WhatsApp Cloud API collection, it's a put request. After many hours of debugging, I actually figured out that there's a discrepancy between Postman collection that they provided and the actual documentation on their website. Instead of put, you use post. The mark messages shares most of the code with our send WhatsApp message method. So let's copy and paste and then modify the data object and substitute with the required parameters for marking a message as sent. The process is like this. When a user sends an incoming message to our API, we acknowledge receipt. Thus, we mark the message as received, the blue ticks. After that, we respond to the message. Our WhatsApp Cloud API token is only valid for 24 hours. So after that, you won't be able to use the WhatsApp API. You will have authentication issues. So in the next step, I'm going to show you how you can create a permanent WhatsApp Cloud API token. Click on System Users and then add a new system user with an admin role. Select the newly created admin system user. Click Assign Asset. Select the name of our application, Artista for our case, and then grant the system user all the required permissions. Then we add our system user to our business account and give them permissions to manage WhatsApp business accounts. We go back to our system user and generate a new token for our chatbot. We have the option of 60 days and a never expiring token. For this tutorial, I'm going to select 60 days. The token must have WhatsApp business messaging permissions. Click Generate, copy the token and replace the WhatsApp Cloud API access token with our newly created token, which expires after 60 days. Let us reload our application to finally test if everything is working. Thank you for sticking around. I hope you now have a comprehensive understanding of how a WhatsApp chatbot works. Looking forward to see what you build next.